In this video, we want to take a look at how we can predict the outcome of an acid-base reaction. And so what we're going to look at is two different reactions that take place with water. So you may remember from your general chemistry class that water could be acting as an acid or it could be acting as a base. It is a substance that is what we call amphoteric, meaning it can be an acid or it can be a base. Whether or not your water is going to act as an acid or a base depends on what it's reacting with. So we've got two different reactions here. So we're going to look at the reaction of water with HCl, and we're going to look at the reaction of water with ammonia, NH3. And so to determine whether or not water is acting as an acid, we want to compare both of our reactants as acids. So that means we want to look at their pKa values and see which one is the strongest acid. So if we look at the pKa value for water, water has a pKa of 15.7. So I'm going to write that on both of these reactions, so 15.7. And then we want to compare it to the other reactant. So HCl has a pKa of -7. Okay, so that's quite a bit lower. And so the lower the pKa value means you have a stronger acid. And so I've been saying HCl to avoid saying the name, which is hydrochloric acid, kind of gives away that that's the acid. But now that we can see, if we're comparing the hydrochloric acid to the water, we've got a really large difference in pKa values. This is a much stronger acid. So that will be the acid in this reaction. So we know that HCl, hydrochloric acid, is going to act as the acid, which means the water must react as the base. And so if we want to determine the outcome of this reaction, we just want to draw the products of water acting as a base and HCl acting as an acid. So we know that acids are going to donate a proton, so H+, and we know that bases are going to accept that H+, okay? That is coming from the acid. So if we want to draw the products here of this reaction, if our HCl is donating H+, it's going to be left as Cl-, and we will call this the conjugate base, because once it has lost its acidic proton, now it is considered to be a base. It's not a strong base at all, though. It's pretty neutral, actually, because that HCl is such a strong acid. And then we want to draw what the product of the water is. If water is acting as a base, it is going to accept a proton. So it's going to add an extra hydrogen. So going from H2O to H3O with a positive charge. So notice our charges are still balanced. These were both neutral. And overall here on the product side, it's neutral because we've got a negative charge and we have a positive charge. So after water has gained that proton, so it's going to go from a base to now the conjugate acid. So let's look at one more example. So if we look at the reaction of water with ammonia, so we still have the same pKa value for water. We're going to want to look up the pKa value for ammonia, and when we do that, we will see that the pKa value for ammonia is 36. So this is higher. And we said the lower pKa value is the stronger acid. So in this case, water is the stronger acid. So in this reaction, it is going to act as the acid, and the ammonia is going to act as the base. And so we can now draw the products of this reaction. So if ammonia is acting as a base, that means it is accepting a proton. So it's going to go from NH3 to NH4+, and we will call this the conjugate acid. And if water is acting as your acid, that means it's donating H+, so it's going to lose H+, and you're going to form hydroxide. And this is the conjugate base.